Hey there, we're going to do a factoring review. Looks like now that we've covered the whole unit, we can review it. All right, biggest things, okay? These are the 5 types of factoring we're going to cover. By no means is this like the only things for factoring. Again, this is, applies for my class, okay? The first one, always look for GCF, greatest common factor. Doesn't matter what type of problem you have. If you are looking at a factoring problem, this is the first thing, always look for greatest common factor. Okay, it's there for many reasons. Sometimes that's the only type of factoring you can do, and other times it's just going to make the rest of the problem easier in that the numbers will become smaller or other forms of factoring are going to be able to be done. Okay, difference of two squares. As the name implies, this can only be done when you have a binomial, and the binomial does have to have a special form, a squared minus b squared. 3 and 4, okay, a lot of books, a lot of texts, a lot of teachers, ways people learn it, separate 3 and 4 into 2 separate ways. Okay, the way we're going to do it here, the way I teach my class, is it's the same way. Okay, there's not 2 different ways to do the same problem. We can do it the same way. And that kind of just makes it easier because it's one less thing to try to memorize or try to learn. Okay, number 5, factor by grouping. Not only is it a way to do number 3 and 4, but it's also a different type of factoring that's a little bit more advanced. When you get to problems or polynomials that have 4 terms or more, then we use factor by grouping. Okay, and then just like greatest common factor is the first thing to always check, the last thing to always check, make sure that you've factored completely. Make sure you can't do any more. Make sure you can't break down something into more smaller factors. All right, so really quick, first one, greatest common factor. Just pull out something simple here. This happens to be a problem that I used in my class. All right, so greatest common factor. The biggest thing to remember is not just greatest common factor, but all factoring. Factoring is the inverse operation of distributive property. Okay, so if we remember, distributive property takes whatever's outside the parentheses and multiplies everything by the inside. The greatest common factor is going to divide everything that's inside the parentheses by the same thing and bring it out. Okay, and the thing that we're going to divide everything by is the most they have in common, aka the greatest common factor. Okay, one thing before we get started here, like I said, factoring is the inverse operation of distributive property or multiplication. So as it is the inverse operation, distributive property always had a problem that had parentheses, and then we multiplied it out. So factoring, since we're going backwards to where we originally started, all factoring problems, when done, should result in problems or terms or factors that are in parentheses. Okay, so we look at what everything has in common. First, look at the numbers here: 36, 28, 40. Right? What's the number that can be that each of these terms can be divisible by? And if we look at it, it looks like a 4. Okay, and if you don't get it the first time, that's fine. You can continue and check at the end of your problem that you've factored completely, and if not, you can take out more. Okay, now each of the letters, so the variables, can be handled separately. X cubed, x2, x to the first, right? The smallest number that they have in common is a single x. And then the last thing we'll look at the y's, y squared, single y cubed, so we'll go with the single y. Okay, hopefully this is a step that you can end up doing mentally, but that's the GCF that you guys have identified, the GCF, and that's the number that gets pulled out at the beginning of the problem. Okay, and when you divide each term, what you have left. So we got 9x squared y plus 7x, y's cancel out, minus 10, x's cancel out, y squared. Okay, so we took the GCF, what we have left, right? What we have is now what looks like a distributive property problem. And that's what we should get because we reversed it. Check to make sure that there's nothing else that can be factored out. 9, 7, and 10, don't think nothing's in common between those. X squared x, this one doesn't have an x, so we can't take out another x. And only 2 of them have a y, not all 3, so we can't factor out a y. Okay, that one is how we do the greatest common factor. Okay, now one common mistake that I've seen in my class, and I'm sure maybe you've done it too, is once you've identified the GCF, it's not that we just divide it out and it goes away. That becomes a factor that we need to still multiply by, right? Because in order to get our final answer, we just multiply this out and check it'll get us this. Okay, that's our 36, this term here, 4xy times 7x, that will get me this, and lastly 4xy times this. Okay, definitely should not forget that. And a lot of the students in my class do that. When you finish a problem, check. Use distributive property, see that the answer, the factored form that you get, equals the original problem. All right, so we'll quickly move to the second type. And the second type is called a difference of two squares. Difference of two squares. All right, now this method, as it would imply, can only be used when we have a binomial, two terms. Okay, so we'll start off with something a little simple here. Something like x squared minus 16. Okay, now as the name implies, what we're looking for is that we have a difference implied by the subtraction sign, and then the two numbers that are separated, or the two terms, are two square numbers. Okay, so make sure that this is something squared and that's something squared. And kind of a way to think about it is just say, all right, what's the square root of the first thing? What's the square root of the second thing? Well, the square root of the first thing would be x, and the square root of the second thing would be 4. Okay. Now the format of a difference of two squares is that one is positive, x plus 4, and then we have the same two terms, but with a different sign, the x minus 4. Okay. So the equation, a lot of people like to remember the equation, is if I have the format a squared minus b squared, that I'm going to just take the square root of each term, a, the square root of the second term, b, and I'm going to put a plus between them, and I'm going to put a minus between them. All right. So we'll do another one here. Okay. Take it up a little bit here. So 100x squared minus 49y squared. Okay, so you're looking at it, you're looking basically for a couple conditions before you can continue to do this problem. First thing, is it two terms? Yes, because I can't do a difference of two squares with more than two terms. Is there a difference? Is it a subtraction? Yes. Okay, and are both the terms that I'm subtracting squares? Well, 100 squared, x squared, yes. 49 is a square number, so is y squared. Okay, question that comes up a lot, or mistake that comes up a lot, is there such thing as the sum of two squares? There is, but not within real numbers. So as long as you're just doing basic factoring, right now we'll just say there's no difference of two squares. Okay, that comes up with imaginary numbers. All right, so again, just kind of look at this and say, well, what's the square root of 100x squared? And that's 10x. What's the square root of 49y squared? Well, that's 7y. Okay, and then your answer is going to be those two factors, one time with a positive, and then one time with a negative. Okay. Now, while we are focusing on the factoring component here, right, if you were to multiply these out, and that's one thing that we do, right, that's how we say we can check this work here, then you will hopefully see that when you multiply these out, why this difference of two scores works. Okay, so let me take the same problem. I'll just check my work. Okay. So if we check our work, and one of the things that I do a lot in my class is we use a box for multiplication. Okay, and I use this box because I'll also be using this for the next form. Right? So we got this area model, right? And if I multiply 10x plus 7y and 10x minus 7y, what's going to happen? Well, the first thing is squared. So square root, that makes sense. The last thing, not only is it a negative, but it's the same thing squared, right? A positive times a negative gets me a negative. And then here's where it makes the whole thing work. When I multiply 7y times 10x, I'm going to get a positive 70xy. But if I'm going to take the exact same terms, right, the 10x and the 7y, and multiply it here, this one is a negative. So this is negative 70xy. Well, of course, if you have the same two terms, and one is positive and one is negative, then those are going to cancel out. So instead of normally, when we multiply two binomials together and get a trinomial, well, now we're going to lose that middle term. We're going to lose the linear term, usually. That's what's in the middle. Okay, so right, normally you get an answer that's a squared plus, what would you put here, bx plus c, but this middle term is going to go away. So we're only left with two terms. Okay, and specifically, just to recap again, difference of two squares, right? If you have a squared minus b squared, you will get the square root of each of those terms, one with a plus sign in the middle and one with a minus sign. Okay, difference of two squares. All right, So this third type of factoring, okay, the third type of factoring is the one that you guys are going to encounter the most. Okay, this is trinomial factoring. So we usually have it just looks like our normal quadratic, ax squared plus bx plus c. Sometimes a is going to be a 1, sometimes a is not going to be a 1. Okay, as mentioned at the beginning, sometimes it's taught in two different ways. Okay, but the method I use, or the two methods I use, are just going to be using the same method. Okay, now of course, with some problems, it's going to seem unnecessary, and the problem might be too easy to factor, but I'm just showing you what works, and of course, if you don't need to use it, then you don't need to use it. Okay. All right. So let's start off with a simple example here. Let's go x squared. We'll keep it easy here and make everything positive so far, because one of the problems that a lot of people encounter are the signs, the positive sign and the negative sign. Okay. Now, right, every time we do these, make sure that first of all you write these in the correct form. Right, the correct form of a quadratic, ax squared plus bx plus c. Okay, sometimes they could be mixed up, sometimes you can combine like terms, but make sure that it's in this form here. All right, as long as you write it in this form, then what I'm going to do is I'm going to play a little guessing game here. And this little guessing game is going to fill in this box. Now I mentioned this box about a minute ago, that if you know how to multiply using the box, then it's going to make sense that since factoring is the inverse of distributive property and multiplication, that I can undo using this box. Okay, so here's how we started. We always put my ax squared and my c term, my first term and my last term, in the first box and the last box. Okay, so in this problem here, the first term goes in the first box and the last term will go in the last box. Okay, it's this middle term, my linear term, that's going to make this problem work. Right? So you need to think of two numbers, you can call them magic numbers, but they have to make something true. You have to find two numbers that when you add them together, they will equal the middle or the linear term. Okay, so find two numbers that add to get positive 5x. Okay, but those same two numbers that you find have to multiply to equal the product of the a and the c, the product of the two outside things, the product. Okay, so add to get the middle, multiply to get what's outside. Okay, in my class I always say that those look like headphones. It's like a DJ. There's your head and your headphones. So add to get the head and multiply to get the headphones, which is a 6 times x squared, so 6x squared. Okay, now a lot of people do this type of factoring in a lot of different ways, and every way you do it, you are thinking the same thing, but it just, each style has its own little nuances. Okay, so you're always thinking of the 5 and the 6, but the x's and the x squared are very important in this method here. Okay, now when you think of the two numbers, right, sometimes it's going to be easier than others, but I always give a tip to think of the multiplication first, okay, because there's a lot more distinct ways to get a product than there are to get a sum. Like if I list out my, how do I get a 6, right, I can find two numbers. That could be a 1 and a 6, or that could be a 2 and a 3. Right, there's no other ways to multiply to get 6. There's tons of ways to add to get 5. Now, if you look at these two numbers, right, you got to find the two numbers, not only that multiply to get 6, which both of these do, but they have to add to get 5. So I actually picked two tricky numbers here. But since everything is positive, right, if I have a positive 1 and a positive 6, that's going to get me a 7. That's too high. If I have a 2 and a 3 added together, that's going to get me a 5. Okay, so these are the two numbers that I want. Okay, so there's a difference whether I take the 2 and the 3 and the 1 and the 6. All right, so we'll pick 2 and 3, and specifically 2x and 3x, right? Because 2x plus 3x equals 5x, and 3x times 2x equals 6x squared. Okay, so you filled in all the products of this multiplication, but because we want to get the numbers that are at the beginning of the problem, now we got to factor out what's the greatest common factor. Okay, so next step here is we're going to factor out the GCF. And this is one reason why when you learn factoring, you know, the first step, the greatest common factor, this is the most important. Because one, not only does it make problems easier at the beginning, but two, it's a step within some of the other methods like this one here. Okay, so how do I factor out the GCF? All right, I look at that here. All right, x squared plus 2x, I would take out an x. 3x and a 6, they both share 3. Up and down, x squared and 3x, they both share an x. 2 and 6, they both share a factor of 2. Okay, we'll talk about the negative signs when they come up, but this one doesn't have it. So this one is all positive values, and my two factors to finish this problem would be x plus 2 and x plus 3. Okay, of course, quick multiplication of that, and you will see that this is the right answer. Okay, now we'll throw in a couple of things just to make this problem a little bit more interesting here. Let's put in a negative number. In fact, let's do the same thing and we'll incorporate that negative solution. Okay, so let's go x squared, and we'll say minus 7x plus 6. Okay, all right, so it doesn't matter that the signs are different, format's the same. If it can be factored, I can use this same method. Okay, if it can be factored. Now, just like all numbers, if you can't factor, you can't break down another number, then it's what's called prime, right? A prime number can't be broken down or factored by anything other than 1 in itself. So here we go. This box, first thing in the first square, last thing in the last square. Looking for two magical numbers that multiply. Multiply to get my middle term. I'm sorry, add to get my middle term, but multiply to get the headphones. Okay, I'll change up the shape so it looks more like a head with headphones. Okay, so 6x squared, and you'll see that this is almost identical to the last problem we did. Okay, so I still want to find two numbers that multiply to get 6, so I'm thinking 1 times 6, I'm thinking 2 times 3, but now they have to add up to get some sort of 7. 2 and a 3, I can't make a 7 out of that. So 1 and a 6 is hopefully what's going to work. In order to add to get more negative, a negative times a negative, right, will get me a negative. And at the same time, a negative times a negative will get me a positive. So I found my two numbers that work. Negative 1, negative 6. Okay, negative 1x, negative 6x. Question might be, does it matter which part I put these boxes in? No, it doesn't. And you can try it, mix it up if you want. All right, here we go. Greatest common factor right here. Now, x squared and x, they both have an x in common. Here's where one of the rules comes into play. Okay, hopefully you've been taught that when you are factoring a polynomial or just factoring anything here, and the first part, the very first term begins with a negative, right? If I just look at this negative 6x plus 6, if the polynomial begins with a negative, it's desirable to factor out a negative 1, just so it could be rewritten without having a negative. So only if it begins with a negative, negative 6x, 6. Doesn't matter the 6 doesn't have a negative here, but if it begins with a negative, I'm going to take it out, and they also both have 6 in common. Okay. Now up and down, I use the same rule for this here, right? If this negative wasn't here, they don't have anything in common. I would just put a 1. But because this up and down is negative x plus 6, it starts with a negative, I am going to take out a negative here. Okay? And of course the first one, they both shared an x in common. So there's my two factors, x minus 1 and x minus 6. Okay, check your work, multiply it out. Sure enough, of course, that's the same thing. Okay, so we'll practice this, a couple more problems, but at the same time, we'll incorporate something else. And let me actually do one more problem just like this before I move on. As my class recently had a quiz, here's one of their problems along the way. So I'm using this video kind of as an instructional thing, but at the same time to review the quiz that they had. Okay, all right, so here we go. Now, again, you know, you're going to get to do these. You can see the numbers that work in your head, right? But of course, the signs are important, and the signs are what's going to make things tricky. So here we go. First thing, first term in the first box, last thing in the last box. Okay, same thing. It's never going to change here. You're always going to add to get what's in the middle. In this case, negative 5x. And you want a product of the headphones, product of the two outside things, negative 24x squared. Okay, so all right, we start by thinking of what's the products that can get me 24, right? Make a little list here, 1 times 24, 2 times 12, what's 24? 3 times 8, 4 times 6. Now you don't always have to write them all out, you just have to look for what you're looking for, right? Can any of these possibly add to get me a 5, in this case a negative 5? Well, I see two numbers that work right here. And in order to add to get a negative number, right, I could do that if I have more negative. So 3 minus 8 will get me negative 5. And also it has to get the product, of course. Positive 3 times negative 8 will get me negative 24. Okay, so that's my good pair right there. And of course, they have to be x's, right? You got to add x's to get x's and multiply x's to get x squares. So we'll go 3 and negative 8. 3x, negative 8x. Okay, GCF. Every row, every column. Okay, take this one first. There's x. This one starts with a negative, so I'm taking out a negative. And it looks like 8. Up and down, they only both share an x. 3 goes into 24, so let's take out a 3. There's your answer. X with a positive 3, x with a negative 8. Okay, go ahead and check it. And of course, those are going to work. All right, so far we've been dealing with problems where the number in front of the x has just been a 1. Okay, but right, as you keep going, they give you harder problems and they put a number up there. They can be anything. We'll just jump straight to, rather than try to make one up on the spot and mess up, I'll just go ahead and take the one I had from my quiz. Okay? All right. Now, again, a lot of students, a lot of teachers teach a different method. Okay? That's perfectly fine. But of course, with 2 methods, you have to have 2 conditions that you need to memorize. I teach the exact same method, not saying my way is better than others, but in the years I've done this, I like it better. Okay, and it all goes back to this multiplication, which is how I teach it in my Math 1 and my algebra classes. All right, here we go. First thing, first box, last term, last box. 2 magical numbers. Add up to get what's in the middle. Positive 8, x. Multiply to get the product. Okay, now 12 times 15. I tell my kids to not necessarily multiply all that out really quick. That's what, 180, negative 180 x squared. Some numbers are easier than others. But the next thing I have is kind of goes more in detail and goes off on a tangent. So we'll keep this like this here. All right, figure out all the factors of 180. If you can figure them out better, like I said, you can stop after you find the one you're looking for. Now, I'm trying to get them to add up to 8. So clearly I got to find 2 numbers that are much closer together than 1 and 180. Okay, and these are the things that you're going to notice when you get farther along and you become better at these factoring problems. All right, so I like to just kind of, not just go through the multiples in my head, but also, if I can double one and take the half of the other, then it works, right? I can double 2, that means half of 90 would be 45. But then, of course, remember other ones that work 3 times, 3 times 60? I can do 5. Well, if I know, like for instance, 10 times 18, right? 10 times 18, then half of 10 means double 18. Okay, 7 doesn't work. 8 would be half of 45. That doesn't work. 9 definitely works. 10, 11, 12. I didn't do 6. 6 times 3, 30. Okay, and if 6 works, then I can double 12 and take half of 30. And let me see if any of these numbers work before I just try to rack my head to keep getting more, right? I need to add to get 8. And, right, one or both of them have to be negative. So how about, does that get me 8 right there? Okay. Now, I need to multiply to get a negative, so one of them has to be negative. But at the same time, I have to add to get a positive. So that means the greater one is positive and the smaller one is negative. The greater one is positive and the smaller one is negative. Okay. All right, so let's put negative 10x here and 18x here. Okay, all right, greatest common factor. Haven't changed anything. All right, be careful, because of course, in order to do it right, you have to do the GCF right. They both have an x, and both of those are even. So let's take out a 2x. 18 and 15, most I can take out is 3. Up and down, 12 and 18. Not only are they even, both, how about 6? They both have 6 times x. And remember, when it starts with a negative, we take out a negative. They both have a 5. Okay. Now, right, I tell you guys, when we get our final answer, we should be able to multiply everything and get what we started with. If you actually just look at this, all the numbers are in place. So you just have to make sure they're correct. The only thing that goes wrong is if you don't take out the right GCF. Okay. Now, of course, 2 times 6 is 12. The 5 and the 3 is the 15. And you just have to check that those numbers get you to the number in between. But 6x minus 5, 2x, and a positive 3. There's my answer. So while you're factoring, okay, a lot of books, a lot of texts, a lot of classes, they're going to emphasize that there's special cases. Okay, we did this special case. There's a difference of two squares. And then there's also these things called trinomial squares, okay, perfect trinomial squares. I don't teach people to memorize them. If you notice them, of course, things are going to go better, but worry about just being able to factor correctly. And if you can factor correctly, it doesn't matter if it's a special one, it doesn't matter if it's not a special one, it'll still work if you can factor it. Okay, so an example of the special ones is this. I will write out the form, okay, after this problem, but hey, we'll just show that everything works the same, and you'll see what I mean by a perfect trinomial square. All right, so here we go. Same thing, have not changed. Now, one thing I haven't done is I haven't thrown in two types of factoring. What I should be doing is I should always be looking to see, do each of these problems have a GCF that it could take out first? Okay, now purposely they don't, but I should be checking them. Okay, nothing, no GCF. So I go to this method here. First thing first square, last thing last square, all right? Add to get the number in the middle, the term in the middle, not the number, the term, negative 20x. Multiply to get the product of the outside two terms. Okay, every term means something. If you change one number, it changes everything. So don't think any of these numbers are not important. Okay, that's 100x squared. 100, easy to figure out 100s. Okay, how do I get 100? 1 times 100, I could take 2 times 50, can't be divided by 3. 4 times 25, I can do 5 times 20? 6 won't work, 7 won't work, 8 won't work, 10. 10 works, 10 times 10, right? And sure enough, that's the one I need. Remember, got to add up to get 20, right? Can I get 20 out of those two numbers? These two, yeah. Okay. Now, both of them have to be negative to add to get negative, but at the same time, negative times negative is a positive. So negative works. Both of them negative. Okay. GCF. Here we go. Running out of ink. Top one here, 4 and 10, they both share a 2. And they both have an x. All right, remember if it starts with a negative, take out a negative. 10 and 25 both have a 5 in common. Up and down, 4 and 10 is 2 again. They both share an x. And again, starts with a negative, take out a negative. 10 and 25 both have 5. Okay, so what you will see here is that my answer is 2x minus 5 times 2x minus 5. Right? Any factor, anything times itself, can be written as that quantity squared. And these types of problems are known as perfect trinomial squares. Okay. Now, if you are to try to memorize these problems, okay, perfect trinomial squares, excuse me, have two formats. It's either a squared plus 2ab plus b squared, or it's going to be a squared minus 2ab plus b squared. Okay. Now, like I said, I don't teach my kids to memorize these. Okay. If you can't memorize something, still understand how you get it the right way, that's good. If you do memorize them, of course that's going to be better for you. Of course that's going to help you along the way, and hopefully you see these. Okay. So when we have a form like this one, because everything is addition, then everything is going to be addition. And the only difference here is that I'm subtracting the two things that I add together, right? A negative and a negative will get more negative, but I still multiply to get a positive. So that's why this one has a minus b. Okay. Now if we looked at this exact same problem, right, this last one we did 4x squared minus 20x plus 25, right? We can hopefully see how this works here. If I look at here and how that relates to a squared, right? What is being squared? Oh, that's a 2x, the quantity being squared. Okay, so I would say a is 2x. A squared is 2x squared. But at the last part also, oh, what do I square to get 25? Well, 25 is 5 squared, right? So b squared is this last thing. If b is 5, okay. Now, if the middle thing works out, negative 2ab, then what I'm looking for is negative 2 times a times b. So if that middle 2, 4, 20 is negative 20x, which it is, then this fits the format of a perfect trinomial square. Okay. All right. A little bit of practice on that. Hopefully that one will come out. All right. So before I go ahead and get to the very last thing, one thing that I mentioned, just kind of as a reminder, is make sure when you factor that you're looking for multiple things. Okay, so factoring is a whole bunch of things, but of course it doesn't mean it only happens once. Okay, so take for example something like 5x squared y minus 125y. Okay, now a lot of people, the first thing they just remember is like, this one has two terms. If it has two terms, I might have a difference of two squares. It even has the minus sign. Okay, but be careful, First thing, always look for GCF, greatest common factor first, and they both have a 5 and a y. Okay, so I can take out a 5y. You should be left with x squared minus 25. Okay, so taking one thing out, that can't be factored, but then I look at this. Okay, that one is a difference of two squares. So if this one can be broken down, x plus 5 and an x minus 5. Okay, don't forget, if you factored it out before, it doesn't go away. Okay, final answer for a problem like this. All right, give you another one here. Okay, so sometimes you'll get problems. They don't try to trick you, but it's more, do you remember to do something? Okay, so here's a good problem. Okay, if you look at that for a second, I'm obviously going to look for my greatest common factor first, always GCF. When I look at this, I'm not going to have a difference of two squares. There's three terms, so three terms can't have a difference of two squares. So I'm probably going to be trying my box for factoring here. All right, so not only can I take out, remember, if your polynomial starts with a negative, we're going to factor out a negative, but they're all even numbers. So I can take out a negative 2, and, they all have at least one x, so I'm going to take out an x. Okay, so if I divide each term, opposite of distributive property, opposite of multiplying everything, dividing everything. So that's going to get me 2x squared. 14 divided by negative 2 is a negative 7. 8 divided by negative 2 is a negative 4. Okay, two-part problem, Just because I factored once doesn't mean I'm done. I see a trinomial. Okay, I know this trinomial. We've been using the box, and the box has been working pretty good. All right, first number in the first square, last number in the last square. Add to get negative 7, multiply to get the product, negative 8. Negative 8x squared. Okay, find the numbers that work to get you an 8. Okay, 8. 1 times 8, 2 times 4. Okay, the only one that's going to get me a combination of 7 has to be the 1 and the 8. One of them has to be a negative if I'm multiplying, and in order to get more negative then, I have to have a bigger negative and a smaller positive. All right, so let's put 1x and negative 8x. Okay, GCF. Top, only x in common. Bottom starts with a negative, and they have a 4 in common. Up and down, they're both divisible by 2, and both have an x, and nothing in the last one, so we just put a 1. Okay, so we just factored this part into 2x plus 1 and x minus 4. We did take out the common factor of negative 2x at the beginning, so there's my final answer. Okay. Please check your work. If you're not sure that what you're doing is correct, you check your work. All right, let's see. Okay, one more. Again, I'm reviewing a lot of my quiz answers here. So if you're just dropping in here, kind of bear with some of these while I throw in some examples. Okay. Now, just as important as recognizing what numbers or terms can go into a factor is to also recognize when something won't work. Okay, otherwise you just try to make up numbers or fudge it. All right, so no greatest common factor. All right, let's do this box here. All right, first number in the first square, negative 36 in the last one. Add to equal the middle number, negative 8x, multiply to get negative 36x squared. Okay, seems like nice numbers, okay, but don't be fooled. All right, how to get 36, product of 36. We can do 1 times 36, we can do 2 times 18, it's divisible by 3, that's 3 times 12. 4 times 9, 5 doesn't work, 6 works. Okay, anything else just goes back up the other way. You have to find the ones that add to get me an 8. That doesn't work. 2 and 18, too big. 3 and 12, I could make a 9 or a 15, but no 8. 4 and 9 can make a 5 or a 13, no 8. 6 and 6, 12 or 0, no 8. Okay, as long as you're convinced that you have exhausted all the possibilities of the factors that could work, but none of them will complete the addition part, right? It has to meet both of these conditions at the same time. Then we don't have one that works. Nothing goes into this, right? We call this prime. There are no two factors, no two binomials that will divide evenly into this other than one in itself. Okay, so that one's prime. All right, going back to kind of one of the quiz problems here. Okay, just kind of another example, right? See if you can do things more than once. All right, step 1, greatest common factor, nothing. Step 2, I want to jump to 2 anyway because I see two things. There's a square number, that's a square number, and it's a difference of 2 squares. So how about an x squared and a 4, right? So you have x squared and 4, one has a positive, one has a negative. Okay, is that wrong? No. Is it right? Not quite. All right, last rule of factoring, always check to see if you can factor completely. This one, this is a sum of 2 squares. Remember, there's nothing called a sum of 2 squares yet. Okay, but this one here, that's a difference of 2 squares again. X squared 4, that's x and a 2. Right? X plus a 2, and then I have x minus a 2. Okay, so always remember, factor completely. Just because you factored once doesn't mean you're done. Okay, now, the last type of factoring is factor by grouping. It's a little bit more intricate, but at the same time, it's a different way to do this box problem. Okay, so if you've watched this and you're like, I don't quite like the box, let me go back a step. Okay, so one of the first problems I did, I'm sorry, I don't remember which one, might have been about the 3rd or the 4th problem I did. Okay, it was this problem here, and we did the box previously, we got the answer, but we're going to do it a little differently. Same thinking, different setup. Okay, now this factor by grouping requires that we have 4 terms. We either start with 4 terms or we make 4 terms. Just like the box had 4 parts, okay? So we set it up the same. We put the first term in the first square, we put the last term in the last square, and we're always trying to find the 2 numbers, right? The thinking is the same. I want to find 2 numbers that equal to get the middle term, and they multiply to get the product of the 2 outside. Okay, so again, if you look back in your notes, you'll see that this is the exact same problem. And then we figure out what works. We figured out an 8 and a 3 work, and I need more negatives. So a negative 8 and a positive 3. All right, so just like I would put these 2 numbers in the box, I'm going to put these 2 numbers in these 2 spaces here. And it doesn't matter which order you put them, but I'm going to put them in this order so I can remind you of one thing in a second. All right, so this is just like I did the box. And after we had put things in the box, we always had to take out the greatest common factor. All right, so this thing called factor by grouping, in order for it to work, is you have to group your terms. We have at least 4 terms, and you have to group them so that you meet 2 rules. The first rule is you have to group them so it's at least 2 terms or more. Okay, so I can't put 3 terms together and leave one by itself. I can't put 1 together and leave the other 3 by itself. Okay, so when I have 4, it's going to be a 2 and a 2. Okay, now the second thing is you want to check that when I take the greatest common factor out, so I'm going to do the GCF for the first parentheses. They both share an x. And the second parentheses. Now remember, if it begins with a negative, we're going to factor out a negative. 8 and 24, they both share an 8. And if I took that out, I'm going to have x plus 3. Okay, here's the second thing about the factor by grouping. In order to do this, the 2 terms that you come up with or leave that's in the parentheses, these have to match. they don't match, try again, or perhaps this method doesn't work. Because in order for these to match, well, what's happening is I have another two greatest common factors. X plus 3 is a factor in both of these terms. So I'm going to take out the GCF again. And of course, when I divide out the GCF here and I divide out the GCF here, I'm left with x minus 8. Okay, and that will be the same answer we got previously. Okay. All right, so let's try this one more, but let's take it up one final level here. Okay, and this was the last problem I had on my quiz. So we got 6x squared. My pen wants to go home. 9xy. Okay. So when you see a problem like this, right, first of all, of course, GCF? No, there is no greatest common factor. I can't do a difference of two squares. This isn't any type of trinomial factoring. Right? There's 4 terms. So automatically, if you're given this in a class, it's a factoring exercise, and you can't do it any of the other ways. It has to be a factor by grouping. Okay, factor by grouping. If I were to just do this, okay, a lot of people, you get this problem and you're not given, you think it's just set up. And you try to take something out. Okay, so both of these have a 3 and an x. And I'm going to be left with 2x minus 3y. And over here, well, lo and behold, this one actually works. It wasn't what I wanted to do, but that's okay. 2x. So I can't take out anything, and if I can't take anything, I take out a 1. And this is 2x minus 3y. Funny, I made the problem. I didn't even proof it. Okay, now again, the key was both of these are the same, so I can take that out. I'll show you an alternate way. That's what we'll get from this here. And what's left after you divide those out is going to be 3x plus 1. Okay, so that actually works. I'm sorry. All right, but here's what, just kind of a general rule. Same problem. Right, if I can pair up out of these 4 terms, pair them up so that each pair has something in common, I could have actually factor by grouped a different way. For instance, I might say, okay, this and this one have an x, so I'm going to put these 2 terms together. And this one has a y, and this one has a y. So maybe I can pair these 2 together. So if I rewrote this, just change the order, a little bit of commutative property here. All right, you will see that I can do this again, and I even get different answers now. This one, they both have 2 and an x, and I'm left with 3x plus 1. This one starts with a negative, take out a negative. They both have 3, and they both have a y. Then I will have 3x and a plus 1. Again, these 2 terms, they match. So I will take the greatest common factor again out of both of those. And what is left is what goes inside or stays inside my parentheses. Exact same thing as what we got above. All right, and that last one, that method is called factor by grouping. All right, factoring is probably the most important skill you've encountered in a long time. Okay, I rank it up there with graphing a line. Factoring is one of those problems or the types of things, the steps that you're going to do, that's just like fractions or simplifying square roots. Okay, even when you're not asked, you should always do it. Factoring is the foundation of a lot of other problems. Factoring will be a foundation for a lot of graphing you do later. Simplifying. Factoring is not going to go away anytime soon. Okay, you want to make sure you can factor well, all right? Because when you are dealing with other problems later, the ability to factor well and to factor quickly is going to save you so much time. All right, don't be the student that's like, I know how to factor, I can find the numbers. Okay, finding the numbers is one thing. You want to be able to find them quickly, of course, accurately. Okay, so hopefully that's a good review. Hopefully you'll go through and practice. And until next time, good luck.